So this is our first line of code. Pretty much what this is doing is creating a basic portfolio tracker that stores the stock symbol and quantities in a list. It creates a list of prices and calculates the total value, and it uses the list comprehension to calculate the position value. Um, so let's run the code so we can go through it. So we can see here it's calculating the amount of shares times the share price to equal the value per stock. So this is pretty basic calculation, but let's go through kind of what all of this means in terms of code. So first we want to create our list. So we're doing that right here in these three. So we have our first list, which is our stock names. So we have Apple, Google, Tesla, and Amazon. And then we have the corresponding stock quantities. So that's going to be 10, 5, 8, and 2. So that means we have 10 shares of Apple, 5 shares of Google, 8 shares of Tesla, and etc. And then we have the stock prices for each one. So for Apple, we'll have 100. The stock price is 180. Google 2,800. Pretty much, you get the deal. So each one of these is kind of linked up to each other. Okay. Sorry about a sneeze. Or not. Okay. All right. So kind of diving into our position values. So we want to calculate the stock values using list comprehension. So our position value is equal to our quantity times our price. So that's kind of how we get the amount of money that we have for I and range Lin stocks. So this is pretty much looping over the list. Since stocks have 4 items, it's going to be through multiplying these two lists here. Um, so this calculates how much money is invested in each stock, and it displays the individual stock values and calculates the total portfolio value in the end. So going to that total portfolio value, um, we have the sum of all our position values. So that's pretty much when we have, you know, 10 times 180, and then 5 times 2,800. We're going to add all that up, or the sum, which the sum function does, and that's going to create our total portfolio value, which is going to be down here. So now we want to display this information. Um, so first we're going to print our stock portfolio tracker. This just kind of indicates in the terminal what this is. You can see that right here. So this is going to loop through each index right here. And it's going to print a formatted summary showing stock symbol, quantity, price, and total value. So the stock I function, this gets the stock symbol, quantities function, this gets the number of shares, the price function gets the prices per each stock, and this is going to be the total position values rounded to 2 decimal places. That's indicated by that F string. Um, and then we're going to print the total portfolio value is going to be equal to the total value to 2 decimal points. As we can see here, everything's in 2 decimal points, gets it to dollars. So yeah. All right. So our second question, we're going to look into implementing a simple moving average calculator. We're going to create a list of historical prices and calculate a 5-day and a 20-day moving average. And then we're going to generate a signal when when the short MA crosses the long MA. So as we can see here, we'll pull up the table. We have our 5-day and our 20-day SMAs. Um, so you can see right here, we have the no answer. So you might ask, why no answer? Because we need historical data to actually get these calculations. So on that 5th day, we can have our 5-day SMA. And then on that 20th day, we have our 20-day SMA. So none of these values will show up because there's not data for that. Um, so, um, uh, So when the 5 day average is higher than the 20-day average, the stock is going up and it's time to buy. And so when the 5 day average drops below the 20-day average, the stock is going down. So it's time to sell. So we can see here, the 5 day is above here, and then it drops below. So we want to sell on this day. So let's look at the code now. So first, we want to store all of our values. So these are all of our prices. Um, so day one price would be 100, day two price would be 102, day three price 101, etc. Um, so looking here, so we want to define a function called simple moving average. This function is like a mini program inside of the program. It does one job for us. This function calculates the SMA, or the average price over the last few days. Um, so looking here, if there aren't enough prices to calculate the average, we're gonna return an empty list. So if we only have 3 days of prices, but we need a 5 day average, it won't work. So that's why we had those NAs. Um, Looking here, this line is pretty much calculating the SMA for every day where enough data exists. It adds up all the last few days and divides it by the period. So for 5 days, it's going to add up that 101, 102, 101, 105, and 110, and it's going to divide it by the number of entries that it took, so 5, and it'll give us 103. Um, okay, so moving on. Uh, this is calculating the 5 day moving average and the 20-day moving average. Now SMA 5 holds the short term trend and the SMA 20 holds the long term trend. So this is creating an empty list signal to store and buy signals. We loop it through each day to compare the moving averages. Um, This are going to be our buy signal. So if the 5 day SMA crosses the 20-day SMA, it's time to buy. We add buy and the day number to our signals list. So pretty much the same thing's going on here. We have our elif function. So if the if function doesn't work out, we'll go to elif. Um, and yeah, it's pretty much the same thing. Cool. So this right here is just going to print our table. So whenever we run the code, um, you should see. Yeah. Uh, yeah, you can see all the variables right here. Cool. So moving down to this, this part prints out everyday stock price, estimates, and trade signals. If the moving average isn't available, it prints NA. Um, and then, so this prints the buy and sell signals as well. And that is the breakdown. All right, so for question 3, we want to create a bond calculator that stores bond details, calculate yield to maturity, and compares multiple bonds using list operations. We first want to start by importing numpy as an NP. This is a Python library that helps with math calculations. We can import it so that we can use functions if needed. Um, Moving on to line 3, we want to define a function called calculate YTM. It takes 5 inputs, which is our face value, coupon, years, price, and guess, um, to calculate the yearly maturity. So uh, max iterations equals 100. That pretty much means that this program will try 100 times to guess the YTM at toll 1e minus 6. This means the calculation stops if it's close or less to 0.000001. All right, so moving on to the next bit. This is pretty much guessing that the YTM is going to be 0.05 or 5%, and we're going to loop it 100 times to adjust to find the right YTM. Um, this means that we are trying to calculate the bond price. So we calculate the price of the bond using the guess YTM. The formula adds up each yearly coupon payment and final face value. Um, yeah. Moving on to this. Diff is the difference between the bond price and the price. So that's what that function does. It finds a difference between. If the difference is 0, we found the correct YTM. If the difference is very small, we'll return the YTM here. This means that our guess is good enough. So this is our derivative. So what we're doing here is just pretty much calculating that. This is a math trick to adjust our YTM guess. It calculates how much the bond price changes when the YTM changes. So all right. So a YTM is going to be equal to the difference divided by the derivative. This narrows down to the correct YTM. Return none here. If the loop runs 100 times without finding a good answer, we'll give the return none. So this function here takes the list of bonds and calculates the YTM for each. This right here. This is pretty much a loop through each bond. We have packets values, which is like the name, the face value, etc. We calculate its YTM and store the results. So this is sorting the bonds from highest YTM first. This helps pick the best investment. If there's a bunch of them, you'd want to see the first one. As you can see here, it's numbered in the best order. So the highest will be first and the lowest will be there. Then we want to store the bond details in a nested list, and that's kind of what we do here. So right here, this is pretty much just comparing bonds to get a YTM for each. And then we want to print the results here. So this is going to print the bond, which will be like this, and then it'll be YTM, which is going to be this here, and it'll to 4 decimal points indicated by the F string here. Alright, that is question 3. Alright, so for question 4, we want to build a price analyzer that creates a numpy array of daily prices, calculates daily, weekly, and monthly returns, and finds the lowest and the highest prices in their position. So looking at this code here, that's kind of what we have going on. You can see in the first 5 days, this is our numbers. Weekly returns, here are their numbers, and our monthly returns are here. Alright. So diving into this code, we're first going to have import numpy as an NP. This is a Python library that helps with math and data. Like we said in the last question, we import it so that we can work with numbers more efficiently. So diving into step 2, we're going to define our calculated returns of prices. We create a function called calculate returns. It takes the list of prices and it will calculate daily, weekly, and monthly returns. So now here, uh, so we want to calculate the daily return. So we have the NP diff prices. This finds the difference between today's price and yesterday's price. The prices in the brackets to -1 takes all the prices except for the last one so that the numbers match its size. So that daily return formula is going to be today's price minus yesterday's price divided by yesterday's price. Um, so moving into our if-else statement. Um, so we first want to check that we at least have 7 days of prices. That's kind of signified by if len prices is greater than 7. Prices in the brackets with 7 takes every 7th price or at the end of the week, so weekly prices. And then the NP diff for weekly prices divided by weekly prices, -1, finds the weekly return, just like daily, but for weeks. If there are less than 7 days, it returns an empty list. Um, so now we have this. So this is calculating the monthly return. So we first need to check it. We have at least 30 days of prices. This is signified by the if len prices is greater than 30. Prices 30 takes every 30th price, like in the last question, and then we're going to do that same monthly prices divided by the diff monthly prices divided by monthly prices. This is going to find our monthly return. So then we want to find our highest and lowest prices. So we have our def find high low. This creates a function that finds the highest and lowest prices and where they happen. So this is finding the highest price with max. An NP argument finds the position or the day that day of the highest price. And the same thing's going on here with the lowest price. So now we have our random seed. So this is creating random prices that are the same every day. The NP random times 2 creates a random changes in the stock prices, and the price fluctuates around $100. So this calls for to find daily, weekly, and monthly returns, and this one here calls to find the highest and lowest prices. And then we want to have everything printed out so we can see it at the end down here in the terminal. And so that's why we have all of our print functions here. And they're indicated by F strings for any sort of decimal or anything going on there. Cool. All right, diving into question number 5. We want to implement a sample asset allocation tool. We're going to want to store the current and target allocations in arrays, calculate the allocation differences, and determine the rebalancing needs. So, diving into the code, import numpy. Like we said before, it's good with numbers and math. We want to define our function called calculate allocation differences. It takes 3 inputs: current allocation, target allocation, and total portfolio value. So, the next step, we want to convert percentages to actual money. So the current values is equal to the current allocation times the portfolio value. This converts percentages into real money, and the equation below does the same for target percentages. So the next step, we want to find out how much to buy or sell. So we have our rebalancing amount equals our target values minus our current values. It subtracts the current money from the target money, and if it's positive, you buy more, and if it's negative, you sell some. All right, moving on to the next step. We have our assets. We're just storing these names here and creating an array. Each one represents a different type of investment. This helps us label and track different types of investments. Moving on to the next step, we want to define our current and target allocations. So, right here, these are matching to the stocks, bonds, real estate, gold, and crypto. And this is kind of our current portfolio allocation. And this below is our desired percentages. So the current allocation shows you how your money is currently divided, and the target allocation shows how your money should be divided. So moving on to the next step, we want to define our total portfolio value. We're just going to say that's equal to 100,000. And then the next step, we want to call the function to calculate rebalancing. So it runs the function calculate allocation differences. It calculates how much money it needs to be moved. So that's going on right here. All right, next step, we want to print out the rebalancing actions. So we want to loop through each asset to print out rebalancing. If it uses buy if money needs to be added, and sells if money needs to be removed. ABS amount ensures that the number looks nice. So it puts it into dollars and quotation marks, and that 2F at the end there is the two decimal spots. So we can see here, it saw that we were over the desired amount by 10,000, so we went to sell. And then we saw in bonds that we wanted to buy because we were under that. And then real estate, gold, and crypto were all the same as we can see up here. And they match, so we didn't need to do anything with them. Yeah, that's question. All right, diving into question number 5. We want to implement a sample asset allocation tool. We're going to want to store the current and target allocations in arrays, calculate the allocation differences, and determine the rebalancing needs. So, diving into the code, import numpy. Like we said before, it's good with numbers and math. We want to define our function called calculate allocation differences. It takes 3 inputs: current allocation, target allocation, and total portfolio value. So, the next step, we want to convert percentages to actual money. So the current values is equal to the current allocation times the portfolio value. This converts percentages into real money, and the equation below does the same for target percentages. So the next step, we want to find out how much to buy or sell. So we have a rebalancing amount equals our target values minus our current values. It subtracts the current money from the target money, and if it's positive, you buy more, and if it's negative, you sell some. All right, moving on to the next step, we have our assets. We're just storing these names here and creating an array. Each one represents a different type of investment. This helps us label and track different types of investments. Moving on to the next step, we want to define our current and target allocations. So, right here, these are matching to the stocks, bonds, real estate, gold, and crypto. And this is kind of our current portfolio allocation. And this below is our desired percentages. So the current allocation shows you how your money is currently divided, and the target allocation shows how your money should be divided. So moving on to the next step, we want to define our total portfolio value. We're just going to say that's equal to 100,000. And then the next step, we want to call the function to calculate rebalancing. So It runs the function, calculate allocation differences. It calculates how much money it needs to be moved. So that's going on right here. All right, next step, we want to print out the rebalancing actions. So we want to loop through each asset to print out rebalancing. If it uses buy if money needs to be added, and sells if money needs to be removed. ABS amount ensures that the number looks nice, so it puts it into dollars and quotation marks, and that 2F at the end there is the two decimal spots. So we can see here, um, it saw that we were over the desired amount by 10,000, so we went to sell. Um, and then we saw in bonds that we wanted to buy because we were under that. And then real estate, gold, and crypto were all the same as we can see up here. And they match, so we didn't need to do anything with them. Yeah, that's question.